Our next speaker is Steve Way. He is CEO of Top Network. Steve is a successful serial entrepreneur that's been involved in companies including WebEx, Sendwave, which was sold to Huawei. Steve has founded Dingtone and operates other apps including CoverMe, Sky VPN, and so forth. So Steve will be talking to us today about decentralized cloud communication network. So without further ado, Steve, go ahead.
So, hello everyone, good afternoon. My name is Steve, CEO and co-founder of Top Network. Today I'm going to introduce a decentralized communication network. So we are seeing a lot of communication services, but it's all centralized. And we are building a decentralized network with blockchain technology. So Top Network is a network, is a decentralized open communication network that provide cloud communication service like messaging, calling, VPN, streaming, all those kind of cloud communication service, plus storage service. So basically, Top is like AWS for communication. It's powered by first generation blockchain technology. For example, like end-to-end encryption, decentralized, so it's secure, private, and unstoppable. And it's censorship resistant, so nobody, even government can stop the network, censor the network. And any application built with the Top network is also secure and private. Let me introduce the architecture of Top network. Let's see from the bottom, it's the network layer. So it has the P2P communication network, has the P2B storage network, and it has a blockchain network. And the network, the server in the network is provided by the community, not from any centralized organization. So there is no we. It's contributed by the community, any individual person, any server, any computer, laptop. And in blockchain world, we call them miners. In traditional world, we call them service provider, right? But in blockchain, we call them node and miners. And beyond that, on top of that is the service layer, so that we can see the communication service it provides VoIP, RCS, VPN, CDN, and IoT plus storage service. And we also have the API and the SDK stack. So people can build a communication app with the SDK. For example, you can build a messenger app with the SDK. That's the whole architecture of Top network. So let me talk about the core value of Top network. It's very different than the centralized version, centralized network. First of all, Top provides very low cost service. The core reason is because it's decentralized. So there is no middleman. Think about it, the AWS has a 60% profit margin. That's the profit. And the Top is decentralized, so no middleman. Everybody contributes servers, and they don't take the profit. So that means the service is very cheap comparing to the centralized version. And so that's a low cost. Secondly, it fixes the privacy and security issue. We all know, Facebook today, even today, is still doing a lot of evil things, right? And WeChat, a lot of Chinese person use is much more worse. But the Top network, because it provides end-to-end encryption, and the user profile is stored on blockchain instead of installed on the centralized server. So nobody can resell your data to third party. Nobody can hack your communication, monitor your communication content. So unlike the centralized version, a messenger app built with the Top network, there's no way to monitor your chat message. Look at the WeChat and the Facebook Messenger, WhatsApp. They can see you. They can view your message. They can archive your message. So it's horrible. So we want to fix the privacy and security issues over in the communication industry. Last, the top network is built with the RCS communication protocol, so it's interoperable. And any application built with the top is interoperable. They can talk to each other. So let me introduce some use cases and what kind of apps can build with the top network. So essentially, you can build any kind of communication apps or any apps with a communication feature with the top network. For example, you can build a VPN apps, messenger apps, streaming apps, and storage apps, video call, audio call. And let me introduce the first decentralized communication app built on the top network. It's a decentralized VPN. The name is a beta VPN. So this is the world's first decentralized VPN app. I have a video. Let's watch that.
BTVPN, a decentralized VPN service, the first app built to the top. BTVPN is the world's first decentralized VPN launch, powered the top network on Stockholm Metro VPN network, contributing to like you, Top network is a decentralized open communication network that provides VPN, messaging, calling, CD, IoT data sharing, storage, and other decentralized communication services powered by blockchain 4.0 technology. Top network includes a mesh VPN network that interconnects thousands of servers and millions of user computers. Each computer acts as a VPN server to know USD tokens as the bandwidth of the country codes. We call it proof of bandwidth, aka P2P. When a user uses a VPN service, the app connects to a node, top network. People report the node based on its bandwidth contribution. How can average you, me, anything it's pretty simple. Take Windows computer for example. The only thing that's to do is to open BTVPN app on PC, then select join top or interface. Click start and finish the installation process. Computer then choose anything else and top. When you go to device service like BTVPN, you can see how much bandwidth you contribute, how many tokens you want to use. Now it's your turn. Your device is chosen to
The BTVPN app is the only VPN survive in several countries, like Iran, like other several countries, because it's built with blockchain technology. So it's very, very difficult to block it. So we know build a communication app is not easy. I have been built many communication business. Started from WebEx. I was the first engineer of WebEx. So I essentially designed the web conference architecture for WebEx. And later I I was doing the video conference business, and I sold the business to Huawei 10 years ago. Later, I co-founded a company, was doing messenger, VPN, those kind of business. And as we know, build a communication app is very tough. You need to build a communication stack as a back-end communication software, and you need to deploy servers. You need a NOC to operate maintaining the network. It's a difficult task. But with the top network, developers is going to develop apps very easily and quickly. The developer just need to care about the user interface. For example, with the top network, you can build a messenger app in a few days. Traditional, maybe you need 1 year or several months, and you need to hire a lot of developers to build audio-video codec, communication stack, and back-end stuff. It's a very massive job. And so it can save a lot of cost for the developer. That's the benefit of building app with a top network. And let me introduce some core technology in top network. As I said, top is a decentralized and a trustless network because the network is from the community, not from us, not from a single company. And so it's become very difficult to, for example, for QoS and security, billing, and ledger. Last session that the professor there, he teased the QoS stuff, but QoS is very difficult on decentralized network. Let me go through one by one. First of all is the QoS. So top is essentially a decentralized SDN. It's a software-defined network. And we have a decentralized control and hierarchical decentralized control that can have an abstract view of the entire network. It's still decentralized. Yeah. So it knows what's happening inside the network, even it's decentralized. Yeah. And second, we invent a technology we call the smart routing. The system can automatically find the best routing path in the network without pre-configuration. Last, we have the proof of capacity of proof of quality. What does it mean? Because the server is not built by us, so we don't know the quality and the capacity of the servers in the network. So we have to implement a decentralized system to detect, determine, and modulate the capacity and the quality of each server. The system is automatically doing this. There's no NOC is monitoring the quality and the capacity of the server. Nobody is doing that. The system is intelligently monitoring that. And security. So, the node, the server is from anybody, right? And we have to assume a server could be evil. You cannot assume the server is good. We have to assume it's bad. And in this situation, how we ensure the security? First of all, we have to adopt the end-to-end encryption. So entire communication session is encrypted, and nobody in the middle can hack the content. For example, say there is a server is from evil government, and the system chooses that server to serve the users, and even in that situation, that server cannot hack into the content. So that's end-to-end encryption. Secondly, the traffic obfuscation. What does it mean? So even the traffic is encrypted, but people may find the pattern. For example, say you visit a special website, it has some patterns. So some evil servers can analyze the pattern and they can filter the traffic. Means it can block you. But we use the traffic obfuscation, so the traffic pattern is hidden. You don't know, what kind of traffic is sending. Last, we are using VRF. VRF is a blockchain terminology. It's called a verifiable random function. So it's used to choose the server to serve the communication randomly. It's truly randomly. And nobody can control the selection process. So it means each communication session, the routing path the server randomly chooses. So make sure it doesn't go to a fixed path and somebody in the middle can modulate the communication. So what we're doing, essentially you prevent the attacking from the malicious nodes. And billing. So how do we log the accurate billing information in a decentralized network? Remember, a node could be evil. They can overstate the workload, the contribution. In a centralized system, you have the billing system, right? You log all the usage. The usage is from the servers, the communication servers. But in decentralized system, there is no centralized billing system, no centralized servers, no centralized database. And each server can report their contribution freely. They can say, I served 10 megabyte data. Another server say, I contributed 1 gigabyte data. They can state any contribution they like. But the system needs to design an algorithm to figure out its true usage. So we have to use several servers in each communication session, and each of them have to reach a consensus. For example, say there's 3 or 4 servers in this VPN session, 4 relay servers. If each of them report a different usage, that means this session will fail because one of them is cheating. The consensus means the 4 relay servers report almost the identical workload. That means this session reached a consensus. That's the exactly accurate usage information. And this information is recorded on the blockchain. Because you know that you cannot change the blockchain information, right? And because it has the consensus from multiple servers, so it's accurate information. Last one is the payment system. So in this peer-to-peer network, decentralized network, there is no centralized company to receive payment. For example, your communication apps use top network. You pay the node automatically, peer-to-peer, not pay to us, pay to the top network company. We are not in the middle. So it has to settle down automatically. And remember, communication service, you guys are all doing the communication business, right? The transaction is huge. And we know blockchain is super slow and very expensive. For example, the first generation is Bitcoin. I know everybody knows Bitcoin, right? Bitcoin, the transaction is, we call the TPS, is only 4. So every 4 seconds, you can only process 4 transactions. And the confirmation latency is up to 10 minutes. Have you guys sent any payment use Bitcoin? You send a Bitcoin payment, you need to wait 10 minutes to settle down. It's so slow. And it's expensive. Each transaction costs about 10 cents. That's the first generation. The second generation is Ethereum. Anybody heard of Ethereum? Okay, good. Yeah. It's getting better. So TPS include 15, and latency reduced 1 minute, typically 20 seconds, and the fee is half cent. But half cent is still too expensive in the communication business. For example, you send a message, and the payment, the transaction fee is half cent. It doesn't make sense, right? So we have to develop a fundamental different blockchain that can handle transaction on blockchain. So it has to be a radical new blockchain platform. So that's what we call ourselves the first generation blockchain. It can handle million TPS. So it has the same capacity like a centralized billing system, centralized payment system, and it's closer to the performance like Visa and MasterCard, and it still has to be very cheap to process the payment. The transaction fee has to be almost zero, 0.00001 cent. And so we invented a very novel blockchain architecture we call the 3-layer ledger. So typically, blockchain has only 1-layer ledger, like Bitcoin, Ethereum, and it's not working in the communication industry because the communication industry is super high volume. So the 3-layer ledger is we have the main chain, and we have the service chain, we have the off-chain ledger, 3 things combined. That's the 2 blockchain stuff, so I'm going to skip this part, those chain stuff. It's very difficult. So our mainnet is already going live, and we are basically the highest performance blockchain platform today on the market. It's designed to process super high frequency transaction like communication, like gaming industry. So Bitcoin and Ethereum is designed for financial industry. Payment, you don't need a lot of transactions. So our mission is to design make a public infrastructure for communication industry, and it's AWS for communication. And you guys, do you guys know the IPFS? It's a decentralized storage layer. It's getting a lot of adoption, and we are going to be the decentralized communication layer for the public. That's all. Any question?
Bring you the mic.
How does it work with the fact that each node on that network needs a round trip, either on a fixed network or wireless? So if my computer is one node, then everyone else has to, the data has to come into my PC and then go back out again. And if it's on the phone, the same thing. So you end up with sort of like the network being in, out, in, out, in, out, because you have to do two trips on the access network for every device, which will add massive latency.
Yes, good question. So remember I mentioned that we have the smarter routing technology. So basically, let's say, we have 2 persons. They start a VoIP session, and they need to make a phone call, right? And there's a client A and a client B, and let's say client A in California, client B in Chicago, and so they need to find a servers. Several servers, and the best one to serve the communications. And for example, your server may be one, but if they find another server in data center, it has much better performance and capacity. So they will choose that one, not you. So they always choose the best servers for the 2 clients to the users. It's randomly, but it's randomly because there are so many servers, but they are going to choose the best ones, or some of the best ones. And this server has the minimum latency and the biggest bandwidth.
What about the latency of the payment mechanism? So presumably there's some sort of back and forth before someone goes, yep, that person has enough money to pay for that connection. You end up with 10 people involved having to pay or receive for every single connection.
Yes.
And how long does it take to set up and agree and clear all that payment before the call or whatever can occur?
Okay, let me go to this one. Right? So each relay server, so this is like a server, right? This is 4 servers. So this is a meeting session, right? And the traffic goes this server, that server, this 4 servers, and each server each server will report the usage, and you cannot cheat the usage because the system has an algorithm to detect that. So in the end, for example, this server contributed 10 megabyte data, and this server contributed 5 megabyte data, and there is a price for the communication. For example, say 1 token per megabyte data. That's the price. It's not free. The network is not free. I think this part gets confused. Yeah. Yeah. So you have to pay the tokens for the network. It's crypto. Not a fiat. Not a fiat. It's crypto. So remember I mentioned settlement on blockchain means use crypto. Yeah, fiat currency cannot support that. Definitely no way to support that. Okay, thank you.
Any other questions? Thank you very much, Steve.